Hello everyone, greetings of the day, and myself T.Vignesh, working as an assistant professor in Department of Mechanical and Mechatronics Engineering in SNS College of Engineering, and welcome to my new lecture series. So in this lecture series, we are going to talk about the heat and mass transfer, the basics, and in this video, we are going to deeply dive into the concepts of mass transfer. Okay, so mass transfer, it is the net movement of mass from one location to another, driven primarily by concentration gradients. So for example, in heat and mass transfer, the mass transfer concepts becomes very much crucial because of the factor of moving of mass. Okay, so basically, as like the temperature, like temperature moves from higher temperature region to the heat is moved from higher temperature region to lower temperature region. Similarly, the mass is also moving from higher concentration region to lower concentration region. So this phenomena, plays a vital role across various scientific disciplines. Like in the case of engineering, in the case of environment, the mass transfer becomes a very much crucial. So understanding the concept of mass transfer uh, is very essential if you are designing a system. So whether in natural systems or industrial applications, you need to understand the mass transfer mechanisms to solve the key challenges. And for example, you take a refrigerator. Okay, so in refrigerator you can see that freezer compartment is placed at the top. Do you know why the freezer compartment is placed at the top? Yes, most of you guessed right that if you place the freezer compartment at the top, right? So the cold air, that is at the top, the cold air, the freezer compartment in the cold air generally moves down due to the density. Okay, and while the hot air moves up, so this is a cyclic rotation. So cold air comes down and hot air moves up. So the hot air again from the freezer compartment, it will be cooled up and it will comes down again. So it is a cyclic rotation, natural phenomena, right? You don't need any now in refrigerator you can convert that freezer compartment into normal section. That is a different part, because see nowadays the systems are evolved, like we utilize so much energy to get that done. But in if you want it get it done by the natural system, so this is the way that you have to keep the freezer compartment at the top for the natural phenomena to be taken place of. And for understanding the mass transfer, again, the diffusion is the movement of molecules from high to low concentration caused by random molecular motion. Okay, so if for example you take a dye factory. Okay, so in that dye disposing in water, it is a prime example of molecules from like high concentration to low concentration. So this is a diffusion kind of a thing, and it is defined by Fick's law. So the mass flux is proportional to the concentration gradient expressed by J, right? And in natural convection, like there are a lot of mass transfer, and these are the concepts which is done by the convection done. And natural convection, like driven by density differences, as I said in the example of the freezer compartment. So it is the phenomena of natural convection. And if we go for the forced convection, like due to external forces such as pumps, fans, so this increases the rate of mass movement significantly. So as you use the fan, okay, so in summer, like you get the air movement rotation, right? So this is a forced convection. And the coefficient K relates mass flux to the concentration difference, quantifying the efficiency of convective mass transfer. And there are additional modes of mass transfers are there, like migration, thermal diffusion. In detail we can see that migration, it is a movement of charged species under influence of like some charging current. Okay, so electric field significant, like as in the case of electrolysis. So electrolysis, if you say that in electrolysis process, anode cathode will be there, and one is charged up by the electric field. So the movement of particles has been taken care. So that is electrolysis process. And thermal diffusion, like it is caused by the temperature gradients where components move from hot to cold regions. And pressure region, due to pressure differences, the mass movement has been taken care of. And there are a lot of applications are there, mass transfer, as I said in earlier, especially in chemical and separation processes like reactors, distillation columns, absorption units. There are a lot of other areas are there in chemical industry as well as the separation industries, like separating the crude oil into different components. So in these areas, mass transfer, understanding the concept of mass transfer plays a crucial role. And biomedical engineering, like drug delivery systems and convection to achieve targeted and controlled release of medications, and environmental aspect as well. So if you want to control the pollution and soil remediation, you have to understand the concept of mass transfer. So optimizing these modes enhances process efficiency, sustainability, and performance across industries worldwide. So that's it for today. Thank you for watching.